Hello students, welcome back to my channel. This time, this is the last video of 2023 Neet exam. Okay, I have come with around 4 to 5 questions maybe from modern physics basically. So let us discuss them one by one. So here comes the first question. The work functions of cesium, potassium and sodium are given respectively. If incident electromagnetic radiation has an incident energy of 2.20 electron volt, which of these photosensitive surfaces may emit photoelectrons? Now, students, as you know that the incident light should have a minimum energy equal to the work function of the substance in order to excite the electrons so that they come out of the surface. Now, the energy of incident radiation is how much? 2.20 electron volt. So any surface having work function less than 2.20 electron volt or even equal to that for that matter can only excite the electrons. I mean, they can make the electrons come out of the. So the only option here appears to be this 2.14 is less than this. So therefore, only cesium is the correct answer. Okay. Then moving on to the next question. The minimum wavelength of X-rays produced by an electron accelerated through a potential difference of V voltage. Now, as you know, X-rays are generated when fast-moving electrons are abruptly stopped by making them strike a heavy metal target. Second thing, you should know that most of the energy which is generated as a result of abrupt stopping of the electrons is simply lost into in the form of heat, but of course a small part of it is converted into X-rays. Now in certain situations, in certain rare situations, the entire energy which is generated as a result of stopping the electron can be converted into X-ray. So if that be the case, then you will get the X-rays of maximum energy because the entire energy of the electrons have been converted into X-rays. So if that be the case, then wavelength will be minimum because maximum energy would correspond to minimum wavelength. So maximum energy would be equal to the entire energy of the electron being converted into X-rays. So energy of an electron is E into V. You know, if E is the charge and V is the potential difference, then charge multiplied by potential difference gives the energy gained by the charged particles. And this will be hc by lambda. So therefore, the minimum wavelength will be hc upon ev. C is the speed of light, h is the Planck's constant, E is the electronic charge. So you can clearly see, students, that E mean lambda minimum is inversely proportional to V. Okay. So these are basically actually 1 by V. This was V square actually. This was V square, students. I'm extremely sorry. And this was root root V. There was a root V also. Okay. So this should be the correct option. Okay. Inversely proportional to V. So here this is okay like this. Then moving on to the next question. The half-life of a radioactive substance is 20 minutes. In how much time the activity of substance drops to 1 by 16th of its initial value? Now as you know, activity is nothing but the rate of change, rate of decay. Rate of decay of the radioactive substance is known as activity. And it also, okay, since minus dN by dt is proportional to m. Okay, So therefore A will be proportional to n, and the formula remains same. That is, the activity at the end of nth half life will be 1 upon 2 to the power n times the initial activity. Okay. Now here, this is, as per the question, this is 1 by 16th of the initial activity. So that can be expressed as 2 power n, is it? So 2 power what will be equal to 16? You know, 2 to the power 4 is equal to 16. So at the end of 4 half lives, the activity would have reduced to 1 by 16th of the initial value. So if each half life is of 20 minutes, then 4 half lives would mean 4 into 20, that is 80 minutes. Okay. Then moving on to the next question. In hydrogen spectrum, the shortest wavelength in the Balmer series is lambda. The shortest wavelength in the bracket series is. So this again based on very simple thing. Suppose we have different orbits of hydrogen atom, different orbits of hydrogen atom. So for Balmer series, you have this. The electron should transit from somewhere higher than n equal to 2 to 2. Now if the wavelength is shortest, that means energy is maximum, and maximum energy would mean that the difference in the energy levels occurring in the transition is maximum. So the electron should drop from infinity to, for Balmer series, 1 by lambda is equal to Rydberg constant into 1 by 2 square minus, it can be 3, 4, 5, etc. etc. Since we are interested in minimum, so it should be infinity. Infinity square remains infinity. This is given as lambda. So lambda minimum is given as lambda. So you have this first equation. Then we have to find the corresponding shortest wavelength for bracket series. So for bracket series, the destination of the electron, final position of the electron is n equal to 4. That is, it should fall from n equal to 5, 6, etc. etc. So for this, 1 by lambda will be Rydberg constant into 1 by 4 square minus n square when n is greater than or equal to 5. So here we have to find the minimum wavelength. So I'll take this as lambda m. 1 by lambda m is Rydberg constant into 1 by 4 square, and it should come from infinity as explained in the previous case. So therefore this will be 1 by lambda m is r by 16. Since so from here you can very easily see that 1 by lambda min is equal to r upon Rydberg constant upon 16, where Rydberg constant can be replaced by lambda by 4. 4 by lambda, sorry, not lambda by 4, 4 by lambda. So instead of Rydberg constant, I can write 4 by lambda into 16. So finally, 4 4s are. So we have minimum lambda is 4 lambda. First option is the correct option. Is it okay? Then moving on to the next question. The radius of innermost orbit of hydrogen atom is this. What is the radius of the third allowed orbit of hydrogen atom? So Bohr's radius is already given as this, and we have to obtain the options in angstrom. So this is 5.3 into 10 to the power minus 11 meter. As you know, angstrom is 10 to the power minus 10 meters. So this is 1 angstrom. So we are left with 1 by 10 here. So this is around 0.53 angstrom, which you roughly take it as half for quick calculations. Now what is the radius of third orbit? Radius of 10th orbit, students, you know it is given by this Bohr's orbit multiplied by n square by z. This is the formula you are supposed to remember. The derivations and all you can get very easily in any textbook. Okay. N is 3 and for hydrogen atom Z is 1. So basically it is 9 times of R naught. So when you put R naught as half, 9 into half is approximately 4.5. So close answer closest to 4.5 is this. So this is the way you are supposed to solve rather than actually going through the calculations. So that's all in this video. Thank you so much.